Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to the Daily Check-In for Thursday, July 16th, 2020. That's right, it's Thursdays, which means it's Thursdays on the edge. We're living on the edge. So today I'm going to be talking about a company that you might not recognize, though you've absolutely used their chips before, and how what they're doing right now relates to enabling some of the edge technologies that we're excited about. So that company is SemTech, and I got a briefing from them last week, and so it got my mind going a little bit, and I thought I would share those thoughts today. So that's going to be the topic. One housekeeping item, in case you're wondering why my broadcasts have been a little late yesterday and today, I am participating in Cloudfield Day 8 with Gestalt IT, and so that's taking up my morning through early afternoon to do that. So these broadcasts are coming out a little bit late, but that's fine. I'm really enjoying the content. Today we had presentations from Morpheus Data and from Diamante, both really interesting presentations, and I'm absolutely going to do a video on each of them later on in the month. Because Wednesdays is my tech analysis day, so I'm going to do it then. Maybe one on Monday too, since I can somehow shoehorn that into professional development. Why not? So that's my housekeeping item, just so you know why this is happening. Be sure to check it out because tomorrow's presenters are going to be pretty cool. Zerto, which is a company I've known for a long time. Curious to see what they have new going on. And the other one is Infrascale, a company that I've never really encountered. So it's a mystery. Could be interesting. Before we get into the topic of today, I want to check in with you. How are you? How are things going? Do you like the shirt? The shirt's kind of out of control. If you're listening to the podcast, I'm sorry, but you're just going to have to go look at the video and check out my awesome shirt. Do you have an excellent Hawaiian shirt that you get to wear every once in a while? I hope you do. Sometimes it kind of puts me in a more festive mood when I might not be quite, in that mood. It helps me, just these little. It's funny how clothing impacts our mood. And when you put on a festive shirt, even if you're not quite feeling there, it might get you there. So if you're feeling a little down today, I know it's not going to fix whatever your problems are, but maybe putting on a fun shirt or a great outfit or doing something different with your hair, I don't know, could help out. Couldn't do worse. So that's my thoughts. Lots going on in the world today, but we're not going to talk about it. We're going to talk about SemTech. So what is going on with SemTech? What do? They create integrated circuits, chips, basically. And what do those chips do? Well, they are basically in the signals processing space. So when you think about two things that want to talk to each other, you're going to have a transmitter and receiver. And there needs to be electronics in those transmitters and receivers. And the more sophisticated the technology is for transmission, the more sophisticated those transmitters and receivers need to be. Now, if you think about something that's relatively simple, like a telephone wire, it's got 4 wires. It doesn't have to transmit a whole lot of data. It's all analog, and it just rides those copper wires. So the transmission and reception is pretty straightforward. Now let's compare that to something like fiber channel. Fiber channel uses laser beams, and those laser beams are analog. They're transmitting a digital signal, but it's in an analog format, and there needs to be something on either end of the cable that does that conversion from analog to digital and then processes that digital signal and sends it along its merry way. That's sort of the space that SemTech is in. They need to be able to interpret the optical signal that's coming in, which is analog in nature, and transform it into a digital signal, do some processing on it, and send it along its merry way. And as we look to increase bandwidth and speeds, they needed to figure out ways in which to transmit more data per pulse of laser. And the way that they figured out how to do this is, if you think about a typical laser, it uses a thing called NRZ, or non-return-to-zero signaling. And it has the capability of basically signaling a 1 or a 0. So it's a single bit that it does it. And basically, if you looked at the waveform here, it looks like a big eye. That's what it looks like. That's the signal. And that signal is able to transmit either a 1 or a 0. And because it's pretty clear, there's a big gap between the 1 and the 0, it's easy to interpret which of those 2 bits it's trying to currently transmit. Now, let's compare that to the new standard, which is called PAM4 for Pulse Amplitude Modulation version 4. So NRZ is kind of like PAM2. This is PAM4. Now, instead of having one big eye in the center, you now have, I think, three eyes in the center, three eyes going across. And by modulating how close the different waveforms are, you can express 2 bits instead of 1. So you can do 1 1, 1 0, 0 1, or 0 0. And for each wavelength or wave unit, whatever they call it, you can now transmit double the number of bits. But the thing is, because you're jamming more information in each of those waveforms, now it's a little bit harder to interpret what's actually going on in that waveform. And because originally when the standard was introduced, the optics weren't great, it was up to the transmission and receiving. It was really up to the receiving end to clean up that signal, figure out what's going on, and then transmit the cleaned up signal in digital form further up the stream. And that process was very expensive. And so the gear to run through that process was pretty expensive. Now, optics have gotten a lot better since PAM4 was initially adopted. And because the optics have gotten better, the signal that's going into the receiver is much cleaner. So you don't have to have as much processing in there. That means a couple things. One, that processing was definitely adding some lag. It needed time to process and clean up the signal. Now that it doesn't have to do that, that lag is gone. That latency has been removed to use PAM4. So that's really important. The comparison that we talked about and during the briefing was if I'm doing 10 gig with NRZ, and then I step up to 25 gig and I'm doing PAM4, I may not be getting that much better than 10 gig because of all the delay from the signal cleanup from the original optics. But now that the optics have gotten that much better, I can run at that true 25 gig with very low latency type of process. That's awesome. The other thing is that the chips are cheaper because they're less complicated. And so the third thing is they require less power. So you're getting more bits per watt, basically, which is a weird way of thinking of it, or more bits per dollar are being transmitted. Now, I'm going to tie this all back to the edge. How does this impact what's going on at the edge? Well, what do we know about the edge? One, we know that low latency is absolutely critical to successful edge deployments. Two, we know that power, space, and cooling is limited. Okay. And three, well, really those are probably the two most important things, the latency and the power. And of course, there's a cost factor to that too, because if you think about the expansion of edge, instead of having 100 endpoints, you might have 10,000 endpoints. And so spending less money on the optics and receivers for all of those endpoints is pretty critical too. So you got three good things going for you there. This is what SemTech is doing. This is how they're expanding into the field. I mean, they're already present in it and they make NRZ gear, but now with the PAM4 gear, they are able to adopt these much higher bandwidth models. So think about 100 gig. That's 50 gig right now, but at 100 gig in the future, and then 400 gig beyond that, being able to get that kind of speed with super low latency at the edge is going to be huge. Plus, the bonus on that is that the cost per bit drops because this gear is not as expensive as previous versions that had to do all that signal cleanup. And you don't need as much cooling, or alternatively, it is, generally speaking, more durable in less hospitable environments. When you think about like the bottom of a cell phone tower or something, that's not going to have great cooling. If this thing's not creating as much heat, then it doesn't have to deal with more extreme temperatures. It's funny because it's not something I think about when I think about the edge. I'm not thinking down at that hardware layer, but the thing that I keep coming back to when it comes to the edge is networking. Networking is key. It's critical to everything. And you need to look at the whole network stack from the very bottom components, layer 0, all the way up to layer 7, and how can you eke out efficiencies at every single point of that stack. SemTech and other suppliers like them are helping you eke out better efficiencies at layer 0 and layer 1 that will now help you with inefficiencies that happen higher up in the stack. So cool stuff. It was a really interesting briefing. Definitely check out the company. It's not someone you would buy from directly, but they're going to be supplying the chips to the cables that you might buy, or the SFP modules you might buy for your data center or for your edge location. So just, keep that in mind. 100 gig is reality, 400 gig is coming, and this is part of the way that we get there. All right, so that's all I have for today. Tomorrow is Friday. It's Vault Friday, which means I'm going to be talking about the next objective in HashiCorp Vault. Pretty cool there. And I am going to talk a little bit about a new project that HashiCorp launched, if I can wedge it in there. So that's going to be tomorrow. Until then, stay healthy and stay safe, everyone.